This is chapter 3, extra example 4 on weight-volume relationships. For this example, we are given the porosity of a sand specimen and then the dry density rho d of this sand. And we're going to determine the void ratio E and the specific gravity of the solids, which is GS. So in this example, everything is given in terms of ratios, and we are looking for ratios as well. So for this example, we're going to assume the total volume V is 1. So let's start first by drawing the phase diagram. So as shown on these slides, we have air, water that filled voids, and then we have solid phase. So for this particular example, it really doesn't matter if you have fully saturated or moist. And since we're given density, so we're going to draw on the left hand side mass in kg, and then on the right hand side at the volume side. As I mentioned, we can assume the volume of either solids or total volume. And for this particular example, we're going to assume total volume is 1 because porosity is given, and this will become clear later. So we're going to assume total volume V is 1 cubic meter. Okay, so that's V. Let's put this on this phase diagram. And for the reason, as I mentioned, since we're given porosity, the definition of porosity is V sub V, that's the volume of the void, over total volume. And then the volume of the voids becomes porosity N times total volume. Since we assumed total volume is 1, the volume of the void in this case is simply the value of that porosity. So it's 0.387. So again, if you see porosity is given, it might be more convenient to assume total volume is 1. And then the volume of the solid, V sub S, is total volume V minus the volume of the void, and you get 0.613 for volume of solids. So basically we have the volume side completed. So we have the two volumes, volume void and volume solids, figured out. So that's the volume side. So next we're given dry density, rho d, which by definition is mass of solid, so that's ms, over total volume. And from this definition, you can calculate mass of solid as dry density times total volume, and total volume is assumed to be 1. So the mass of solids is simply 1600 kg. So we can put this on the phase diagram. That's 600 kg. For this particular example, we are going to calculate void ratio in specific gravity, so we don't actually need the weight of water. And the void ratio E is volume of void over volume of solids. If you plug in the two volumes we calculated, you get 0.63 for the void ratio. And then for specific gravity, the definition we talked about is unit weight of solids over unit weight of water, which is the same as density of solids over density of water, which is basically mass of solid over volume of solids. And if you plug in the mass of solid from the phase diagram and the volume of solids, 0.613, and density of water is 1000 kg per meter cube. If you plug in all these numbers, the specific gravity of the solid is 2.61.